Today we're going to be looking at angles of polygons, particularly starting with the polygon interior angle sum. So it says the segments that connect the non-consecutive vertices of a polygon are called our diagonals. We're going to use our diagonals to help us develop the formula, which they give us right here, part of it. It says drawing all the diagonals from the vertex and polygon, so a polygon with however many sides, separates them into n minus 2, so the number of sides, take away 2. And then we can find the sum of the measures of those based on our triangles. Because we know inside of a triangle, such as this one right here, I have 3 angles here, and we know the angles of a triangle have to equal 180 degrees. Okay? So using that information, we can then go through and help us derive an actual formula we can use. So looking at this piece right here, I'm going to draw a diagonal in this one. Make my pen a little larger here. Then we'll draw from this corner to this corner. This is a diagonal, going from one vertex to another. I have separated this thing into 2 triangles. This one is 1 triangle. So I know this one is 1 times 180. Gives me 180. This one I have 1, 2, so it's going to be 2 times 180. So that tells me a quadrilateral has 360 degrees. Looking at a pentagon, I'm going to pick an edge here, a vertex. I'm going to start with this one, and I'm going to make a diagonal here. Notice I didn't go to this one because that's a consecutive vertex, so I have to go to a non-consecutive. Going from the same one here, I go down here. I have now divided this into 1, 2, 3 triangles. So I'm going to do 3 times 180 because remember we know that each triangle has 180 degrees. So that tells me a pentagon has 540 degrees inside of it, if I added up all the angles of my pentagon. Looking at one more shape here, my hexagon, I pick an edge here, a vertex, and I'm going to go across here. That's a diagonal here, a diagonal here, and a diagonal here. I now have 1, 2, 3, 4 triangles, so I'm going to do 4 times 180, which would give me 720 degrees. Notice the pattern we've got forming here. This one has 3 sides. This one has 4 sides. Here we have 5 sides, and this example here has 6 sides. The relationship between these says we're going to take the number of sides and subtract 2 and then multiply it by 180. So depending on what size my polygon might be as to how much I have to multiply it by. So using this formula, the polygon interior angle sum theorem formula, I can figure out, hey, what's the sum of my measures of each convex polygon? So a decagon, well, first we have to remember a decagon. How many sides does that have? Well, based on our root word here, deca means 10, so this is a 10-sided polygon. 10 sides. 10-sided polygon, so n equals 10 for our formula. So my formula says that I have to take and do 10, take away 2, and multiply that by 180. Well, 10 take away 2 is 8 times my 180. I multiply those together. 8 times 0 is 0. 8 times 8 is 4, carry a 6. That'll be 8 plus 6 is 1,440 degrees. So if I added up all the angles inside of a decagon, they would add up to 1,480 degrees. I can do the same thing with a 16gon. 16gon is just a 16-sided polygon. So this would be my n. So I'm going to do 16 minus 2 times 180. So that gives me 14 times 180. I multiply these together. And as I go through and multiply them together, I find that we have 2,520 degrees inside of a 16-sided polygon. 30-sided polygon, same thing. This is my n. So I'm going to take, and using this formula over and over and over, 30 minus 2 times 180, which this gives me 28 times 180. I punch that into my calculator, and I get that it is 5,040 degrees. An octagon. Now octagons, in fact, using our verbiage, our language, first I need to remember how many sides does an octagon have? Well, the root part right here tells us octa, just like an octopus. An octagon has 8 sides, so this is 8. So I'm going to take and do, so this is my n. So I'm going to do 8 minus 2 times 180. So that'll give me 6 times 180. 6 times 180 will give me 1,080 degrees. My 12-sided, 12 minus 2 times 180. So that's going to be 10 times 180, or 1,800. Here, 35 minus 2 times 180, which that'll give me 33 times 180. Which is going to be 5940. It does not matter how many sides you have. You take the number of sides, subtract 2, and multiply it by 180. And that'll tell you what the sum, all the angles added together, of our polygon happens to be. We can also use that then if we're dealing with regular polygons. Here, our regular polygons, we actually have to remember that all the sides are congruent and all the angles are congruent. So we're going to have to do a little bit of algebra backwards on this and figure out a little bit of solving. So I know that n is the number of sides. N is equal to my number of sides. So if I have a regular polygon and I use my formula n minus 2 times 180, and then I divide that by n, that will give me one angle inside of my regular polygon. Well, here they've told us that, hey, that one angle is 150 degrees. So how many sides do I have? So I'm going to plug it into the formula here. So I'm going to have 150 would be equal to n minus 2 times 180 divided by n. I'm going to multiply both sides by n now. Multiply this side by n. Multiply this side by n. So I have 150 n equals n minus 2 times 180. Distribute my 180 into here. So I have 150 n equals 180 n minus 360. Now I got to get all the n's on the same side, so I'm going to move. Normally we move the smaller one, but that would add extra steps, so we're going to take and move my 180 n to the left, to the left, to the left. We got to move it to the left, to the left. And I see that I have negative 30 n is equal to a negative 360. One more step. I'm going to divide both sides now by negative 30. The 30's here. Divide out making 1, leaving n, which is my goal. How many sides does my polygon have? 360 divided by 30 tells me that it's going to be 12. So one angle of a 12-sided regular polygon is 150 degrees. Let's look at number 8. Now with number 8, we're going to go ahead and do a little simplify, because every time if I take my one angle and multiply by the number of sides, that has to equal my n minus 2 times 180 every single time. Well, I know my one angle in this case is 160, so I'm going to do 160 n is equal to, and I can go ahead and distribute this in here just like we did the last time. That's 180 n minus 360. This portion right here is going to be the same every single time. Now I move my 180 to the left. We'll pick it up and say to the left, to the left. Let's move this thing to the left, to the left. And now we've got a negative 20 n is equal to a negative 360. And we've got to divide both sides now by negative 20. Negative 20. I see that the negative 20s, these divide out making 1, leaving n. Over here, negative 360 divided by a negative 20 tells me that this one has 18 sides. It's an 18-sided regular polygon. Looking at our next example here. So I can start off with the 175 n is equal to 180 n minus 360. Subtract the 180 from the right, 180 from the left. I now have negative 5n is equal to a negative 360. Divide both sides by negative 5. The number of sides for this one, is going to be, well, this one goes in here 7, and then we go in here again 2, 72 sides. And we can kind of go through and keep doing the same thing over and over. But we can also take and use this information here to help us actually solve problems with this. So if I have an example like this one right here, it says find the value of x. Well, first off, I need to know how many sides does this polygon have? I have 1, 2, 3, 4, 5. So if I take and do 5 minus 2 times 180, that tells me that I have 540 degrees inside of this polygon. So I can now add up all these other pieces here together. So I've got 7x. I'm starting right here, and I'm going to go around this thing clockwise to make sure I collect all the pieces. So 7x plus 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10, and all that has to equal 540 degrees. Now on the left hand side here, let's collect all of our like terms. So go gather up all my x's, because all my x's live in Texas. Okay, so let's see, I've got 7 and 4 is 11, 16, 17, 21. I got 21 x's. Sounds like some people I know. Next, I gather up my numbers. Notice here I got a positive 5 and a negative 5. These two cross out, making 0. And I got a 10 and a 10, so that gives me 20. And that equals 540. I'm going to take and subtract 20 from both sides now. So minus 20 minus 20. I see that 21x is equal to 520. Now I have to divide both sides by 21. And I go through and I divide this out. And I see that I can't add, actually, because I have gone through and realized that, oh, wait a minute, I missed one of these out here. This should be 26. Oh, now we can finish it. Pay attention. It's okay to make mistakes when you're doing things, but make sure you can go back and catch your mistakes, because 7 and 4 make 11, 16, 22, and another 4 gives me 26. So now I divide both sides by 26, and I see that x is equal to 20. The value of x for this particular problem is 20. Now we're not only going to look at just the inside of our polygons. We have this other one here. It says the polygon exterior sum, exterior angle sum. Simple relationship for our exterior angles for a convex polygon. It says polygon exterior angle sum theorem. The sum of the exterior angle measures of a convex polygon, one angle at each vertex, is equal to 360. So this one plus this one plus, so this angle here plus this angle here plus this angle here, 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 and here. If I add each of those together, so this angle and this angle, each of these together, they add up to 360 degrees. So looking at my questions here, it says find the sum of the measures of the exterior angles of each convex polygon. So I got a decagon. Remember, that one has 10 sides. So if it has 10 sides, the sum of the exterior measures, oh, that's 360 degrees. Wonderful. How about one that's got 16 sides? Whew, that's a lot of sides. Guess what? It's 360 degrees. And what about if it has 36 sides? You got it. 360 degrees. Exterior Angle Sum Theorem. Polygon exterior angle sum theorem says if you add up all one angle at each vertex, then they add up to 360. So looking at this, says find the measure of each exterior angle for a regular polygon. Oh, that word regular again, meaning that they are all the same. So if I got a 12-agon, I'm just going to take 360 and divide it by 12. My formula for this would be 360 divided by the number of sides. So in this case, 360 divided by 12, well, 12 goes into 36 3 times with a 0, 30 degrees. A hexagon. Hexagon has 6 sides. So I'm going to do 360 divided by 6, 60 degrees. What about a 20-gon? 20-gon, that's a silly name. 20-gon says, well, I just do the same thing. 360 divided by 20. That will go into here 18 times. 18 degrees is what each of them will be. A 40-gon, same thing. 360 divided by 40. That one will be 9 degrees. A heptagon. Oh, we haven't come across heptagon. Hepta, this means 7. So this one has 7 sides. So I'm going to do 360 divided by 7. So, oh, I don't think that comes out nice and pretty like all the other ones have. Well, let's see. 7 goes in here. That'll be 5, and that leaves me 35. So that leaves me at 10. That goes 1 time, and that leaves me 3/7 degrees. 360 divided by 7. Not a pretty number. Oh, and look at this. We already did that one, so pay attention to what you're doing. If you've done it once, don't go do it again. Remember, always try to work smarter, not harder. Nothing wrong with hard work, but if we can, let's help ourselves out. So, sums of interior angles are going to be the number of sides minus 2 times 180. Exterior angles. Angles, boy, can't spell today. Angles, that one would be 360. Use these to help you solve any problems you come across dealing with interior angles of polygons. Have a great day.